All right, so I should have started it before, but we have that an exponential equation is an equation with the variable in the exponent. In the exponent. Incidentally, if you're writing things down, you don't necessarily have to just write down what I write down. Put your own little notes or things that you think might be useful to know later. We're not just doing all kinds of exponential equations today. We're doing ones that have bases that are related to each other. So we're doing things like 2 to the x equals 8, 2 and 8, or 4 and 8, or 3 and 27 down below. Okay, 3 and 27. This is not going to be so obvious why this is going to involve related bases, but it will once you get started on that. Or even it might not be obvious why this and this are related, but we will get that eventually here. We are not going to do equations right now that are things like 2 to the x equals 7, because the bases aren't related. Okay, but we'll more on that towards the end here. I am going to give you a kind of a simple little hint for how you can approach this, and then you're going to try some, and then we'll come back to compare things. Sometimes along the way there's little thought bubbles and stuff. Make sure you read those. It might give you an idea of how you can do things. This equation you could probably do just by looking at it, right? You can do that just by looking at it. What's the solution? To solve it, we want to know what x is. What's the solution there? 3, right? X has got to be 3. What you're thinking is you're just thinking, well, 2 to the what power is 8, right? 2 to the what power is 8. 8 is 2 to the third, right? Really, you're saying 8 is like 2 to the third. You're writing this, you're thinking of that as a power of 2, because the other side's a power of 2, right? What you're doing is you're saying, well, if I have 2 to the x on one side and I have 8 on the other side, I need to think about what is 8 if I think of it as a power of 2. That's the concept here is, if you're trying to equate two things, whatever they happen to be, the first thing you want to try is, can I write them as powers of a number that's the same? Because if you can write them as powers of a number that's the same, then it's pretty straightforward for how you can solve it. If the bases are the same, then the exponents have to be the same. Even if it's a little tougher once you do that, right? So here there's the exponent, or the variables in both of them have an exponent and the variables on both sides, but you can still approach this the same way. The hint is going to be exactly this. If you can try and write both sides using the same base, that's the only sort of new thing, or that's the strategy here. When you first learned to solve equations, you learned, I have to isolate the variable, right? If I had an equation that was like this, 3x plus 2 equals 11, you learned your strategy was isolate the variable. You learned all kinds of things like, well, you can do this first and then you can do that, and you can do a whole bunch of different things, but if you had to summarize the strategy of how do you solve linear equations like that, you do it by isolating the variable. For exponential equations where the bases are related, the strategy is this. Try and write both sides using the same base, as powers with the same base. If you look at that second one, you have a 2 on one side and an 8 on the other side. You can write both sides as powers with the same base. 2 and 8, they're both powers of 2, right? 8 is 2 to the third. 2 is 2 to the 1. You don't even have to change it. Over here, this one, maybe it doesn't look like you can write them both as powers of the same thing. 8 is not a power of 4, right? You can't say 4 to the 2. 4 to the 2 is not 8 or anything like that, right? But they are both powers of 2. You can use the same base. This is 2 to the third. This is 2 squared. So let's do that second one. If I'm going to write the second one using the same base, I don't even have to change this side because it's already a power of 2. But this part in pink there, the 8, I can change that 8 to 2 to the third. I'll put brackets there just to maybe show that I made that substitution. All you did is change 8 to 2 to the third. Now maybe it's not obvious why that helps, but it does because you can start to simplify that. From this point on, you just need to be reminded of things you already know, such as, how do I deal with this when I have something like that where it's a power of a power? When you first learned this in grade 9, you probably didn't look at it with variables involved, but it's the same concept. You probably looked at it like this: 2 to the 3rd to the 4th. How do you simplify an expression where you have a power of a power? You might remember, is it 2 to the 7th? Is it 2 to the 12th? Is it something else? Not sure? You multiply them. If you're not sure why you multiply them, think about what powers mean, right? Instead of trying to just think back to what you were told to do, think about what powers mean. If you have 2 to the 3rd just by itself, it's like, how many 2's do we have? We have 2 times 2 times 2. If I say now I have that to the power of 4, I have this thing how many times? 4 times, right? I got that written out 4 times. I don't want to write them all out here, but if you have this, you got it written out 12 times. It's 2 to the 12th, right? You multiply those. So here, even though we don't know what that x is, we can write it out in a simpler way as 2 to the, what would I do if I multiply these? What am I going to have? 3x plus 3, right? That's the new part up to there. Well, and I guess the one next step, which is sort of just using intuitive logic, right? If you're just intuitively thinking about what happens next, I guess the concept would be, let's say you had 2 to the a equals 2 to the b. You were all logical enough people to be able to tell me what must be true. If 2 to the a equals 2 to the b, what has to be true? Yeah, though these have to be equal. If the bases are the same, the exponents have to be the same. So if 2 to the 5x equals 2 to the 3x plus 3, 5x has to be equal to 3x plus 3, right? And then it's just a linear equation to solve. You've kind of simplified it down from an exponential. You've made it a simpler linear equation. So you have 2x equals 3, and you have x is 3/2, or you could write it as 1.5. That's your solution. If you wanted to check your solution, you could ask your teacher. You could ask the person next to you, but what might be a better, more independent way to check your solution? I'm sorry, what? Yeah, just put it in, right? You have this, and, as much as I would like you to be able to solve this without a calculator, check it using a calculator if you want, right? Go to your calculator or whatever, and 2 to the 5, and put that number in, right? 1.5. And see what that gives you. And then do the other side, which is 8 to the 1.5 plus 1. And check that, and just double check that they're both equal. I'm sure you can do that pretty quickly with whatever calculator you happen to have. If I do 2 to the power of, now you're not going to put it in the calculator exactly how I have it written there. If I do that, it's going to give me the right thing. If I do this, it's going to, well, let's do the other side first, and then we'll talk about the wrong thing. If I do this 1.5 plus 1, probably you can do the 1.5 plus 1 in your head. But if you don't trust your head, then you can always do that. You're going to get the same thing so long as you've entered it correctly in the calculator. You might think you're entering it correctly in the calculator and put something like this. What's the problem with that? Yeah, the calculator is going to do standard order of operations. The calculator is going to think you want it to do this first. So if you want it to do, even though we write it as this, and you don't put brackets around it, or this, and you don't put brackets around it, there's kind of implied brackets here that you need to put on the calculator. All right? Are we okay with this? So, because you're going to get the wrong thing there. You could always waste your money on the fancier calculator and then download the newest operating system, my calculus class, some students discovered this last year, that if you go on TI's website, if you have this calculator, and update your operating system, I don't know why they were doing that, but they were. It looks like this now. 2 to the power of, except this virtual one, you see how it does that? 5 times 1.5. Then you don't have to worry about that because it is even, it's more how you write it. I think that's pretty cool, actually. But anyways, whichever, it doesn't matter. Speaking of calculators, you don't have to. I'm going to stop this now. Yeah, I want you to work through the rest of it here, and we'll stop and talk it a few times, but just apply that concept.